Okay, hello, we're group 4. My name is Maggie Zhang.
My name is James O'Rourke.
I'm Xiaodan Wang.
I'm Qinxue Li.
And I'm Alexis King.
Okay, so let me first do an introduction of our second project. So in our first project, we did a study of avocado prices throughout 2015 to 2018 in Chicago. And we looked at some basic stats such as mean, median, frequencies, and variances. And in our second project, we'll be focusing more on studying the relationships between variables such as prices, volume, sales volume, and the time. And we basically use the same raw data as we did in our last project. And in this project, we also focused on Chicago region and on organic types of avocados prices through 2015 to 2018. So basically, our codes are the same in terms of filtering out the specific data to narrow us down to only organic avocado prices in Chicago. So there are some key questions that we're trying to answer in this project. They are how the prices of avocado change as time changes, and what's the relationship between the price and volume, price and time, and if the actual prices of avocado, how does it compare to a prediction?
So first, we imported our dataset to Python, and we are using the same code in the previous project. And then we're using the describe function in data frame to display the main statistics in this dataset. And this code is also the same as the previous project. And the next output shows the top 5 rows in our dataset, and we're still using the same code in the project 1. And next, we're change the date column in our dataset to time series using the datetime function. And since we decided to focus on Chicago area, we've filtered our dataset to display the data points in this area. And this code is similar to the code we used in the previous project. And also, there are 2 types of avocados, and we chose to analyze the organic type. And the above output shows the top 5 rows in the data frame organic dataset, and this code is the same as the previous project. Next, we decide to use the additive model to demonstrate the time series forecasting, and therefore we calculated the monthly average price from 2015 to 18, which would be used for our additive model. We constructed the additive model with the observing graph showing the true data points. The trend model shows the general trend of the dataset, and the seasonal graph shows the repeated short-term cycles, and the residual one shows the random variation in the dataset. From this graph, we can see that the organic avocados has a general upward trend in Chicago and the repeated seasonal patterns, and the residual plot has a random pattern indicating a good fit for a linear model. The next plot is a trend plot. Based on this graph, we conclude that while there are some fluctuations in the prices over different times in the year, the organic avocados in Chicago have an upward trend over years. The next plot is a seasonal plot. This one shows that there are repeating short-term cycles throughout the time series.
All right, next, we're going to take a look at autocorrelation. So we really just wanted to see how the price of organic avocados really kind of moved with the times and see if we see any trends in that. So at first we started off kind of showing all of our observations. So we set our lags to 38 so that all 39 observations would be showed, but it was just a little bit too noisy. So we decided to just cut it down to 24 and only show the first 2 years of our data set. So that's January 2015 through the end of December 2016. So autocorrelation just looks at how values in the time series correlate to each other when they're X amount of periods apart. And so in our autocorrelation plot, 1 period is equal to 1 month. So overall, looking holistically, there isn't much correlation between the prices, just kind of overall, but you'll kind of see like the exception in the first year, so period 7, 8, and 9, so that's July, August, and September. We see that like these prices are kind of strongly correlated with each other. And then in year 2, we see September, October, November, and December, they're also kind of strongly correlated with each other. So in the terms of our project, this just kind of shows us that the average price of organic avocados in Chicago during period 7, 8, and 9 in 2015, and then 9, 10, 11, and 12 in 2016, they're closely correlated to one another. And we're kind of saying that these prices are kind of depending upon each other. And the trend we're really seeing is that kind of in the second half of the year, kind of moving towards the end of the year, that's kind of when we see correlation for prices of avocados and the time, whereas you don't really see that correlation at the beginning of the year. And so now I'm going to pass it to James.
I'm going to discuss a little bit about the R model. So this model, the ARMA model summary results. So when we take a look at these summary results right here, you notice that the AIC and the BIC are both relatively low numbers, which indicates that this model is actually a fairly good fit for the data. Also, based off the results, you see that the MA.L1.average price variable, which represents noise, has a relatively high coefficient compared to the other ones, which means that noise is definitely like in the data, and it's definitely influencing the data set. And also looking at the model or looking at the results, you can see that the P greater than Z values, we want those to be less than 0.5. And as you can see in the results that there's only 2 that are close, and the 2 that are close are AR.L2 average price and then MA.L1 average price. And those both have a 0.067 and 0.077 respectively. But we concluded that since they're relatively close to 0.05, we decided that they would have an impact on the model and the overall data set as a whole.
Okay, so now I'm going to talk about a residual graph we got. So basically this residual graph shows us that how the actual prices varies from the predicted prices. So you can see there's a huge drop in the December 2016. Basically, something happened in the market that caused it. So this price drop actually correlates to the graph shown above right here. So basically, both of these 2 graphs confirm that there were some contingency happened at the end of 2016.
Okay, for this part, we use histogram to capture the average price of organic avocado in Chicago, and we noticed that the price falls around $1.6 to $1.7 most frequently. And density plot shows more clearly how the price distribute, and the conclusion consists to the histogram. While using KDE to model average price, we are also thinking about another variable, total volume. Is price and volume correlated to each other? To figure out the answer, we set up KDE model. We set up KDE model for volume as a control group and to grab a rough understanding of how volume data distributes. It turns out that the total volume of organic avocado in Chicago is concentrated around 30,000. To further study about the correlation, we compute a density estimation in 2 dimensions. And from this plot, we can roughly see that data is concentrated at this part. And since the histogram are bent and could be overwhelmed, which could make a visual understanding of density difficult, So we also create a better plot shown as below. And from this advanced plot, we find that when price is concentrated around $1.6 and the volume is concentrated at 30,000, there is not a simple negative correlation between volume and price, which means that the lowest price is not necessary to generate the highest total volume sold. And when the market price is raising up, the highest point is raising up to the highest point, the volume will be more likely to concentrate around 30,000 rather than decline to the lowest volume point. And according to that, we draw a conclusion that the organic avocado market in Chicago has its own sensitivity of what price for what volume is appropriate.
So just to wrap up the project, we just wanted to have a few concluding key findings. So one of those is that by studying the relationship between the prices of the avocado and time, we learned that during 2015 to 2018, the prices have been gradually growing throughout the years, other than one little fall in 2017. But overall, we think that the organic avocado price in Chicago will steadily keep growing over the next few years due to the trend that we have identified. One limitation that we'd like to mention in this is that we only have data for 3 months in 2018. So that kind of affected our ability to perform a proper analysis on the organic avocado prices in Chicago in 2018. Two future questions that we would like to ask on this data set would be, number one, since there's a deep decline in the price of avocados in January 2017, we want to examine the reasons behind this decline. And number two, after analyzing the correlation between price and volume, we found out that two variables kind of interlock with each other in a complex way. We still are not sure which one is the trigger variable, or there could be a lot of noise that exists between these two variables. So in the future study, we want to generate more data and also analyze different types of avocados and the price volume relationship in other regions as control groups, just so we can examine our conclusion that we've drawn. Thank you.